We are talking about solving absolute value inequalities. And here we have two examples. And what we want to do is basically we're going to solve it the same as we solve the equations, but we have to pay attention to what our inequality sign says. So if it is greater, so we talked about this a little bit earlier, greater means that the compound inequality has or it's going to be the union. So we're going to do the same exact thing that we did before. We're going to write down the equation twice, or the inequality twice. But what we have to do is we have to use the conjunction or. So we also have to account for the same thing. When the expression in between the absolute value sign is positive, so in that case, we're just going to write down the inequality as we see there. So absolute value of 3x minus 2. No, sorry, we don't need the absolute value. So just 3x minus 2 is greater than 7. We do not need this absolute value over here. And then we also have to account for when the expression between the absolute value is negative. So if this value is negative, what we have to do is we have to change the sign on the right from positive to negative. So we're going to have 3x minus 2, and now we have a negative 7. So when we change the sign, that's like multiplying by negative. So whenever we multiply or divide by negative, we have to change the direction of the inequality sign. So we have to make sure we change that sign there. And then we just solve these two inequalities, same way that we would any other. Add 2 to both sides, and we get 3x is greater than or equal to 9. Divide by 3, and then we get x is greater than or equal to 3. The next one, same thing. Add 2, and then we get 3x is less than or equal to negative 5. Divide by 3, and then we get x is less than or equal to negative 5 over 3. So we have our two compound inequalities, and remember, this is greater than. So we have greater. So this is x is less than or equal to negative 5 over 3, or x is greater than or equal to 3. So we can write this down, usually write the smaller version on the left. So in set builder notation, we have x is less than or equal to negative 5 over 3, or x is greater than or equal to 3. That's set builder notation. Or that means union. So then we can do interval notation. So negative 3 or negative 5 over 3 is the top limit. This arrow means it's going to negative infinity. So we know that this goes to negative infinity from negative 5 over 3. Because it's equal to, we know that negative 5 over 3 is included, and infinity and negative infinity are never included. And then we have x is greater than or equal to 3. That sign says that it's going to positive infinity, and it's coming from 3. The sign underneath says equal to, so we know that that's included, and infinity is never included. So we go ahead and graph it on the number line. We'll just pick some points. It doesn't have to exactly, I guess we can put 3 here, a closed dot, because it's included. So 3, 2, 1, 0, 5/3, 3, 2, 1, 0, -1. So it'll be right about here. Another closed dot that represents -5/3. Variable on the left with the arrow pointing to the left, so we know that it's going to go this way to negative infinity. And we know that variable on the left with the arrow pointing to the right, so the arrow points in the same direction, and that's going to positive infinity. The next one that we're looking at is problem 4, and we have absolute value of 1/2 x minus 2 is less than. So we want to remember less than. So not spelled correctly, but that will help us remember what we need to keep in between our two inequalities. So we have it written down here. We want to get rid of that absolute value. So we want to do it once with positive, once with a positive value in between the absolute value. So we get 1/2 x minus 2 is less than or equal to 3. And then we have to also check for when it could possibly be negative, when the expression between the absolute value could be negative. And in that case, 1/2 x minus 2. Now we're changing this to -3. And whenever we change that to -3, that's like multiplying by -1. So we have to change the direction of the inequality. Then we can go through and we can solve. So first thing, we add 2 to both sides. You know, 1/2 x is less than 5. Then we multiply both sides by 2. And then we get x is less than or equal to 10. Next one that we come to, do the same thing. We're going to add 2 to both sides. And then we get 1/2 x is greater than or equal to -1. We're going to multiply by 2. And then we get x is greater than or equal to -2. So because it was less than, we got to remember that our conjunction is and means intersection, or it has to be in both solutions. So if we're going to write it in set builder notation, I always want to write the smaller number on the left. So in this case, the smaller number is -2. So here we have -2. Now, -2 says x is greater than or equal to -2. One way we can do it is we can just remember to flip it, or we can remember that the small arrow has to point towards -2. Small arrow has to point to -2, so that means the opening has to point to x. And then this one is all set up right because the x is on the left, so we don't have to do anything with the sign there. So then we're all set. -2 is less than or equal to x and less than or equal to 10. When we write that in Interval notation. We just write that down. We have -2 and 10. -2 is included because of the equal sign, so we use a bracket. 10 is included, so we use the bracket. And then we go to graph that. We have -2 over here, and then 2, 0, 2, 4, 6, 8, 10. So that worked out. Just use that as a placeholder. They both have closed dots above them, and we want to draw the line in between.